All right. Yes, we have to do work today. We have to. We have to. No, they caught up now. That's because I told you that story. Kids are nothing but trouble. No, I think about that every day, actually. Especially when I'm driving to school, I'm thinking, that's right, I got to look at that.
Mr. Johnson, next hour.
Next hour.
More active participation.
We'll make a whiteboard day, just not today.
What is your favorite color?
Now that's a stretch right there, I'm telling you. Okay, well here's the reason why. We're on this. We are on this timeline that we have to meet, and because believe it or not, like I have things planned out all the way until the end of the third quarter and spring break. Okay, so we have to meet that deadline. Okay, which is still like 4 weeks away. All right, and if it just trust me, the timeline has to work. Okay, so we have to finish up these things. Today we're going to do this. Monday we are doing section 5.4, which is e to the x, e to the u. And then Tuesday I've got another one of those meetings with the whole math department. So I'm not going to be here. So I'm going to give you a worksheet. Yeah, I know. What we're doing is we're considering a new textbook adoption. Okay, and the textbook adoption is going to affect then all the math classes at the high school. Okay, and we're deciding what route we want to go. Okay, and it's quite the ordeal. So, but I'm not going to talk about it right now, even though I would. But we got to get going. Okay, so we have what we're learning in Calc 1 is specific integration techniques that work for certain scenarios. I don't know if you have felt this, but as you do your homework, you'll see that every single one of the problems works out nicely. That when you pick your u and then you find the derivative of u, would you imagine that? That's found somewhere in the remaining part of the integral. Okay? And that's because that's u substitution allows you to integrate those certain types. Okay? This one here is a special type. E to the u is a special type. And then when you take second semester calculus in college, not if. When you take second semester, like half the semester is all about learning more integration techniques for problems that we don't handle in Calc 1. Okay, so it's remember when we said we can find the derivative of any function? That's actually true. You can just make up whatever you want to, and you know all of the techniques that can handle any derivative. Not so much the other way around. It's harder to integrate than it is to differentiate. And so we only cover certain ones in AP Calc, which is semester 1 Calc. And then you do more of them in Calc 2, you do a little bit in Calc 3, and then when you take advanced calculus, you learn other techniques. But it's not like there's one size fits all. There's just like, okay, for this situation, you got to do this. For this one, you got to do this. So anyway, this what we're studying here today is when you have a scenario where you can put it into the form of 1 over x or 1 over u. Okay? So every single problem that's in this section can be isolated. You can say, oh, I spy a 1 over x or a 1 over u. Okay? So what did we say yesterday? The integral of 1 over x dx was the natural log of the absolute value of x plus the c. Okay, so we established that fact. We kind of even proved it using visual and how that works. So if I just simply change the variables, it's the same deal. So the integral of 1 over u du is the natural log of the absolute value of u plus c. Okay, no big deal. But what this allows us to do is realize that, hey, you can now do a u substitution. So now we're going to combine u substitution with the new thing, this thing. Okay? All right, so take a look at this one. So it's the integral of 1 over 5x minus 3 dx. Okay? So you look at it over here, and is it just 1 over x? No. It's 1 over some function. Okay? So in this problem, what you do is you choose to do u substitution where you let u be 5x minus 3. Okay. Now where does that lead you? Well, you can now write this as the integral of 1 over u. So now it matches this one. Okay. Now the only thing is we have to convert our dx to a du. And the way you do that is exactly the way you did it in the whole last section. We spent lots of days on that. So as before, you'll always take the derivative of this function here to get your du dx. So du dx equals just 5. Then you do the thing. You multiply both sides by dx. And then you solve for dx. So it's 1/5 du is equal to dx. This part of it is no different than what you've done now for like a whole week. Okay. So we see we handle this part of it right here. That's 1 over u. So the only thing left is to substitute the dx, and so the dx is 1/5 du. Okay? U substitution, but now with a different application. Okay? So this, as everybody knows, is the same as this. It's 1/5 times the integral of 1 over u du. That's just rewriting it. And then we integrate. So the integral of 1, I like to say sometimes like this, the integral of 1 over something, okay, the 1 over something is then equal to the natural log of the absolute value of the something plus c. Okay, because really it's anything. It could be a theta, it could be whatever variable that you want. And then we just have to put it back into x's. So it's 1/5 times the natural log of the absolute value of 5x minus 3 plus c. That's all there is to it. The secret in this kind of problem is to do the I Spy game and find out if you can put it into this form. Okay? If you can put it into this form, then we got ourselves a deal. Okay? So this is an indefinite integral, so let's take a look at a definite integral. Okay? So here we go. You look at it and you say, with all of the with everything that we've learned up to this point, if you exclude today, we can't do this one. Okay? You just can't do it. You can't divide that up or anything good. So you have to apply the combination of the new thing with the u substitution. All right. So just to clarify, I want to make sure that everybody sees this, that this is the same as the integral of 1 over x squared plus 1 times x dx. Okay? That's a fundamental thing that you see, that means the same exact thing as the one above. The x is just being multiplied here. But here, it's x over 1. Here, we just put the x over the x squared plus 1. This is fundamental that you see this, because it allows you to see where the 1 over u is going to be. Yes? Right. And then if we added the 1, we get the 0. Exactly. Good call. All right, so who's u? X squared plus 1. Okay. Now we're going to do the thing. So du dx is equal to 2x dx. And ultimately, you see that we get 1/2 du is equal to x dx. And that's what we're going to use. Okay, I forgot to put my 0, my 3 on here. Okay, so what we're going to do is we're going to do the change in variables technique. So I'm going to go into the u mode, and I'm not going back to x's. So let's do that. So this means that this thing is the same as the integral of 1 over u times 1/2 du. You see that? This is just doing the substitution. We got this part and we got this part, and we're writing it as those two separate things. Okay? All right, help me out on my limits now. No longer are my limits 0 and 3. What's my lower limit now? 1. You take the x equals 0, plug it in for x squared plus 1, and you get 1. And then what's the upper limit? 10. 3 squared plus 1 is 10. So that's an important thing, that you see that as soon as you go over to here, now there's nothing that's weird. This is okay, this is okay. That's important. Okay, well, let's finish this off. So I'm going to take the 1/2 out. And then, if you don't mind, I'm just going to go ahead and integrate. 1 over u du is the natural log of the absolute value of u. And we're integrating from 1 to 10. You see it? Okay, so then we plug this in. And I can say 1/2. And then there's a thing here. Sometimes, like if you're in a different math class or a calculus class, the teacher might do this. Okay? Which is fine. That just means that, okay, I'm going to leave the 1/2 on the outside. And then I'm going to do the natural log here. So it's the natural log. 10 and 1 are both positive, so I don't have to put the absolute value. So I'm not going to. So it's the natural log of 10 minus the natural log of 1. And it ends up being the same as if I put a 1/2 natural log of 10 minus 1/2 natural log of 1. Okay, so sometimes you'll see this notation. Okay, do we know either one of these? Natural log of 10? E to what power gives you 10? Not an easy one to do. Okay, so we just leave it. Natural log of 10 is still a number. Okay, just not a counting number. Natural log of 1? 0. E to the 0 equals 1. So that's how we know that. So the final answer here is 1/2 natural log of 10. So if we were to graph this function, whatever it looks like, I don't know what it looks like, and find the area bounded by that from 0 to 3, the actual answer would be 1/2 times the natural log of 10. Make sense? Yes.
So if you wanted not to do changing variables, if you just put it into the natural log and put in x squared plus 1 to
You'd put the x squared plus 1 in here. This would still be 0. This would still be 3. And then when you plug it in, believe it or not, you get a 10 and you get a 1. Yes.
Is it wrong to write the equation like, instead of the first step in 1 over u times 1/2 u, yeah, and then have 0 and 3 on the middle?
No. No, that's where when I first started doing it, it's like, okay, this is a problem because we're mixing up the two worlds is what's going on. So if you don't want to do the u thing like this, I should say, if you want to go to u and then go back to x's, I just wouldn't write those here or here until I finally wrote the x's. Then we know that we're not talking about the same thing. Okay, let's do another one. Okay, you guys are getting the hang of this, right? That's it. And I'm not going to tell you how to do it. Think. Think. I'm not going to tell you anything. You can talk with other people if you want to. Talk it out, brainstorm. Just a what? Got it? Have I taught you nothing? Does anybody know when class ends? Oh, good. You could have said 52. Okay, what's the trick in this problem? Rewriting it as sine divided by cosine. So sine of x divided by cosine of x. Why does this help? You should see that this is then the same as the integral of 1 over the cosine of x times the sine of x. You see it? So who's u? Cosine of x. So u is equal to cosine of x. What's the derivative? Negative sine of x dx. So there's the other half. We're looking for, we needed a sine of x, so we got one now. And then, but we got this negative that we've got to move to the other side. So multiply both sides by -1. That does the trick. Goes back to our derivative. Derivative of, yeah. This is where it gets confusing. You got to go back to last semester. Derivatives. Derivatives. Derivative of the sine of x was cosine of x. Derivative of the cosine of x was negative sine of x. Okay? So, I know, this is what gets weird, because then, when you go backwards, it's the opposite. Okay. So, this means that this bugger is 1 over u times negative du. Does this make sense? It just all works. So this means that it's equal to the negative natural log of the absolute value of u plus c. And then we got to wrap it up. So do the plug-in. Okay. So it's a negative natural log of the absolute value of the cosine of x plus c, which is what you would find if you Googled it. Okay? But now you know why the answer is that. It's the I Spy game. I spy a 1 over u. So look over there.
Whenever there's a 1 over u.
Whenever there's a 1 over something.
Okay. So that's
Because it goes back to, if I rewrote this as u to the negative 1,
then you.
add 1, you get the 0, and the world blows up, and then it's bad news. Okay, last one. Last one. Choose your u very wisely. You got a 50-50 chance here.
I have a question.
Yeah.
How come you just like if I didn't know that we were recording this, I would look at that and try to use the power rule.
Right. If you use the power rule, the world would blow up. Yeah, it's u. Oh, yeah. The power rule only works when it's a polynomial, like an x. But a tangent of x, you can't say tangent squared divided by 2, because it doesn't work. If you find the derivative of it, you see it just doesn't match. Okay, what are you thinking? Who should you be? Nobody wants to be you. And you don't have 2 u's. Who would be the right choice for you? ln x. Because, why? The derivative of the natural log of x is 1 over x dx. So, this is du is equal to 1 over x dx, which, would you believe that? It's sitting right there. What? So this actually isn't really hard at all, because look at it. This is all it is. So, final answer, we know that. That's just like our fundamental thing. Natural log of the absolute value of u plus c, which is the natural log of the absolute value of the natural log of x. And that looks weird. Yeah, it's the natural log raised to the natural log. Because you just bring it up. All right, do your homework. You can now do this homework 5.2.
What is it?
Monday.